In this project, I use horizontal port autoscaler to make the deployment for the front-end and back-end applications autoscale when needed. Right now, they have only one port in them, so I'm gonna uh, test the backend first. So as you can see, the load increase. As the load increase, the port the deployment scale out like this. So the backend have 5 port right now, rather than one port. So we're gonna test the front end deployment. As we can see on the screen, the load for the front end also increased. Uh, at the same time, the deployment for the front end also scale out. It is 5 now. So in this project, I also use Kubernetes network policy resource to put the restriction on the traffic inside the EKS cluster. So these are the network policy resources. So this is the one for the front one POC. So basically, it say that it will allow the front one POC to have outgoing to have only the outgoing traffic to the backend POC inside the station namespace. And this is for the DNS server. So network policy is effective only in the EKS cluster. So for the RDS instance to allow only the traffic from the backend POCs, we need to use security group for POC. I also set up security group for POC in this project. Normally, POCs cannot have security groups because they cannot have their own elastic network interface. But once security group for POC is set up, some POCs can have EMIs. Uh, for example, this is the front end POC that has this EMI. Basically, every POC with this label will have this security group and EMI. That is why this port has this EMI. This is for the front end port, and this is for the backend port. I configure this security group to make this backend port allow traffic only from the port with this security group. So I'm gonna test that. This is the front end port, and I'm gonna run some command on it. I'm gonna send an API request to the backend port. It got response, so the connection was allowed. So I'm gonna run the same command on another port. So it hang. That means the connection wasn't allowed. Project I also implement the external secret operator. This is the architecture diagram of the ESO. So the cluster sequence to resource, we see that it will use AWS service. The external secret resource uh, basically create Kubernetes secret based on the AWS secret manager resource. So this is the manifest file of the external secret from Argo City. So it basically say that it will look at the AWS secret manager resource with the name of staging-sm, and it will create Kubernetes secret and name it station-db-cracks. I'm gonna prove that. So this is the deployment. So in the backend deployment, the credential should not be hard coded. It is not hard coded here, but it will be received at the runtime. So it has it. So I have spent almost 2 months on this project. I have also solved a lot of issues along the way, but I don't want to include the extensive list because it would be kind of boring and overwhelming. So I only include the list of the problems I learned the most from. Uh, so the link is included in the README file of my project repo. I also include the reasoning uh, behind my solution. Thank you.